Hi, AB Calculus class. We're working on 2010 number 5, and notice we're working on A and B only. C is a great question. It's insanely hard, and the year it was given, most people got 1 out of the 4 points for that. It's not on your quiz. It's probably not going to be on your AP exam. So, we might look a bit at part C, but you don't need to do it. Okay, at least the starting point. All right. So part A asks us to find g of 3 and g of negative 2. So again, we're doing part A. And before I can find out what is g of 3 or g of negative 2, I'm going to start with g of 3 because they asked me. Important, this is the graph of g prime x. Straight line, semicircle, straight line, great. And here's the thing. They give me, and you always have to read the fine print, some initial information. G of 0 is 5. And this is key. And in fact, if you just did the previous question, they also gave us g of 0 is 5. Interesting how that happens sometimes. So, remember the rule. If I know the area underneath f prime x from 0 to 3, what does this give me? The area underneath f prime x gives me the net change in f of x. Meaning if you took the antiderivative of this, the antiderivative of f prime x is f of x, and then if you plug the top and the bottom and subtracted, this is what you get. So the area underneath f prime x tells you the net change in f of x. And if you rearrange this equaling these two things, you get our formulas we use. The final is initial plus net change, and the initial is the final minus net change. So in this problem, we want to know how much did f change from 0 to 3. So these are our two things. This is what we want to know, this is what we know. And if you compare these two on a number line, 0 comes before 3, so 0 is the initial, and we want to know the final. So the final position is the initial position plus the net change in position. So the area underneath g prime x from 0 to 3. All right, so let's go ahead and start with g of 0. We know what g of 0 is. It's 5. So our answer is going to be 5 plus, and then we just need this area. What is the area underneath g prime x from 0 to 3? Well, if I'm going from 0 to 3, you will notice we have 1/4 of a circle and part of a triangle. So the area from 0 to 3 underneath g prime x is 1/4 of a circle plus a triangle. So let's go ahead and do those two things. Let's start with 1/4 of a circle. A circle is normally pi r squared. However, this is 1/4 of a circle, so it's 1/4 pi r squared, and this circle has a radius of 2. So that's the quarter circle. Plus, remember these areas, since they're above, when they're above the axis, we count it as positive area. And then this triangle, so this is also going to be added to this. The triangle is 1/2 base times height. That's just the area of a triangle. The base of the triangle is 1. The height of the triangle is 3. We are done. This is my answer for g of 3. G of 3 equals all of this. Initial plus net change. Net change is the area underneath g prime x from 0 to 3. We do not simplify. You do not get any extra points. So we're done. That's part A. Part of part A. Let's go to the second portion of part A. So the second part of part A wants us to find g of negative 2. So we still have to start with our only initial information they give us, which is g of 0. But when you compare g of 0 and where 0 and negative 2 are on a number line, this one actually comes first. So we have the initial and we are given the final. So it's final minus the net change. So from negative 2 to 0, we need to know how much does f prime x change. So again, final minus net change. All right. So how are we going to find this? Well, so our answer begins with our final. Our final is 5. We know that. Minus the net change. The net change is simply what's the area from negative 2 to 0. Whoa, negative 2 to 0. That's just this quarter of a circle. It's a quarter circle. So it's a quarter of a circle, so it's 1/4 pi r squared. I guess I didn't need brackets or parentheses. And the radius is simply 2. Done. So this is g of -2. Could you simplify it? Sure. Are we going to simplify it? Nope. All right. That's part A. All right, so let's talk about part B. So for part B, they want us to find points of inflection. And if you just did the previous question, you know how to find points of inflection for g of x. Points of inflection are where the second derivative changes sign. So we would want a sign chart of the second derivative, g double prime x. And this graph goes from -7 all the way to 5. Now, we have the graph of g prime x. We want the sign chart of g double prime x, which means we're going to have to look at slopes. The slopes of g prime x tell us about its derivative, g double prime x. So if we look at slopes, positive slopes all the way to -2. Notice the slopes stay positive. Even though there's a sharp turn, the slopes stay positive all the way to 0. From 0, now my slopes are negative. So now I have negative slopes all the way to 2. And then I have, so again, my slopes were positive, positive, negative. Now they're positive all the way to 3. So positive slopes to 3. And then from 3 to 5, negative slopes. So again, my slopes were positive, positive, negative, positive, negative. Okay, now, if you did not label your sign chart, you can't use what we're using here. But let's go ahead and look. The second derivative is positive. That means g is concave up. Still concave up. Concavity didn't change. That's not a point of inflection. Changes from concave up to concave down. Changes from concave down to concave up. And concave up to concave down. So we will say g has points of inflection at x equals 0, 2, and 3, because, and this is important, g double prime x, I've labeled a sign chart so I can do this, g double prime x changes signs. What would you have to do if you did not make a sign chart? If you did not make a sign chart, you could talk about this graph. And you could say they are points of inflection because g prime x changed from increasing to decreasing, or from decreasing to increasing at those points. And you could do that as well. You could say g prime x changes from increasing to decreasing, or from decreasing to increasing at those points. And that is another way to justify it. All right, I'm going to start, that was part B. Part B. Done. Okay. I want to talk about part C, just the beginning of it, but we're not going to solve the whole thing. It gets crazy. So part C, they give me some new thing and they say, hey, let h of x equal g of x minus 1/2 x squared. And then they ask for the critical points of h. This is the only part I want to go over. Where do we get critical points? Critical points are where the derivative equals 0. So I would need the derivative. So the derivative of h of x is h prime x. The derivative of g of x is g prime x. And here the derivative of the 2 goes to the front. That makes a 1, and then the exponent goes down by 1. So the 2 goes to the front. It's a 1x to the first. If you took the derivative and set it equal to 0, that at least gave you 1 point. It's really, really hard from here. To finish the question, you'd have to add the x to the other side. You'd have to find out when is g of x equal to x. And you'd have to think of it as x as the graph of y equals x. And then you'd have to find some fancy math to figure out that's the square root of 2. We can use a 45, 45, 90 right triangle to do that, and at 3. And then you'd have to do some sort of sign chart to then prove which one was the max or min. It's a lot of work. It can be done. But it's not on your quiz and it's not on your AP exam probably. So I just wanted a critical point. The derivative is 0. And we didn't have the derivative here, so we had to take the derivative and then set it equal to 0. And sometimes you can't finish a question, but if you can just say, hey, critical points are where the derivative is 0 or undefined, good. One more thing about critical points, they can never be endpoints, okay? You see this -7 and this -5, they can't win absolute max, they can only win absolute max or mins. They can't be critical points because they can't be relative maxes or mins. They can't be points of inflection. Endpoints can't be critical points. They can't win anything except absolute max or min awards. Okay, anyways, that's it for this question. See you later. Thanks for watching.